Hi guys, so this is going to be the last part of this learning target, and it is what we call a launch problem. Okay, so we're going to start with the problem that was here in our notes packet. And it starts with Paul launched his Angry Bird. It traveled a horizontal distance of 100 feet and reached a height of 80 feet at its highest point. Sketch the path of the Angry Bird and write the quadratic equation that models it. So all of these problems are going to be set up the same way, and it's going to be a path. So he starts here, let's say, for example, and he launches this Angry Bird and it goes in a path that looks like this. Okay, not the perfect, but you get the idea. Okay, which is basically a parabola that is opening down, okay, upside down. And so if we're thinking of this as a parabola, we have a highest point here, we have a starting point, and we have an ending point. Okay, so we're going to call this starting point 0, 0, and that's our x and our y. And then we have this ending point, okay? We have a certain distance that it's traveled, and hang on one second, guys. Sorry. We have this certain distance that it's traveled, which in this case is 100 feet, okay? A horizontal distance of 100 feet. So it lands 100 feet away from where it started, but it has a height of 0 because it's on the ground. And then we have this other number in our problem that says it's a height of 80 feet. So right here we have our height, okay, that's our maximum, that's our y value, and our x value. If you remember when we talked about our parabolas, your vertex is exactly halfway in the middle of your graph. So halfway between our starting point, which is 0, and our ending point, which is 100, halfway between that would be 50. So that gives us a vertex, which is our h and our k, of 50, 80, okay? And this is another xy. Okay, so now we have all of our points labeled. Now we're going to use our basic formula that we talked about for transformations and for quadratics, which is vertex form. So we have y equals a times x minus h squared plus k. Well, if I look at my equation, I have a value for y. I have two of them actually, two possibilities. I don't have an a value. I have an x value. I have two to choose from. I have an h value, and I have a k value. So right now it says sketch the path, which we did, and then write the quadratic equation that models it. So this is your quadratic equation. And what we need to do is plug in the values that we have and then find the only one that's missing, which is a. And then we will have the equation of the path that this Angry Bird is following. So when we go for when we choose our values for x and y, you have two possibilities. But I will tell you that 0, 0 is always the easier one of the two. So we're going to use this value for our x and our y. So I see y and I plug in 0. I don't know what a is, so I'm going to leave that as a. X is also 0. I come up here, my h is 50 squared plus my k, which is 80. And now I'm going to just simplify this, okay? So I have 0 equals 0 minus 50 is negative 50. And on my calculator, I'm going to do negative 50 squared. And I get positive 2,500. And I'm going to put my a right at the end there. You can put it in front, but you guys are pretty much used to just putting variables after the numbers. So that's what this whole part is right now, plus 80. Okay, I'm still trying to solve for a here. So that means I'm going to subtract my 80 on both sides. I have negative 80 equals 2,500 a. And my last step to getting a is to divide by 2,500 on both sides. Okay, those are going to simplify to 1. And then I have negative 80 divided by 2,500 on my calculator. And I'm going to leave this as a fraction. So this simplifies to negative 4 over 125. Let's make this a little more obvious here. Now, the fact that this number comes out to be negative should tell you something, okay? We said when our a values are negative, it flips our graph. And if you notice, this one is upside down. Okay, so it should be a negative. This is my a value. My very last step is to rewrite this as an equation using just a, h, and k. Okay, when we see these equations and we're graphing them, we always only ever see the x and the y left in there. So I'm going to rewrite this as y equals, I have my new a value, x minus 50 squared plus 80. And you are all done. Okay, and the nice thing is that this is going to be the same process that you're going to follow for basically any problem like this, where you know where it starts, where it ends, and what your vertex is. Okay, and that's it.